Hello, everybody. Welcome to SRA 365. I'm, of course, Professor S. This is today's lecture. Let's get into it. So, here's the practice problem solutions that we're due for today. Oop, I'm in the way. Here we go. And there we go. Okay, so anyways, today what we're doing is we are talking about log linear analysis. We're going to talk about what the heck that is. We're going to perform it and choose the best model. Really, the focus is going to be on how you do it instead of so much why we do it and that sort of thing, or like why it's working and that sort of thing. We'll get into a little bit of it but really the focus is it's like you be able to make those models and choose the best one. Okay, so why are we choosing those models? Remember, with chi-square, what we're doing is we're comparing at most two categorical variables together. But what if you have multiple categorical variables that you want to compare with each other and then also together? Like you need like a better way, and that's where log linear analysis comes in. So first of all, the assumptions remain the same as chi-square, which we didn't talk too much about, but here they are. Its observations must be independent. That means, like, if you think of the contingency table, and you know how like it's kind of tallies up the different values that like satisfy each row and column respectively. Each tally is representing one thing, right? So if we're thinking about store and burger preference that we talked about before, each cell, like if they said Wawa and I don't know, beef, right? A normal hamburger, that would be one person. And they don't also say chicken or vegetable or Wawa, right? It's just sheets and beef. That one person's there, right? So each person is independent. That's kind of what we're talking about. Each observation is independent. We also assume that the observations or the expected values are greater than 5. If you've ever gotten a warning from that the like values might not be accurate, it's probably because you had an expected value that is less than 5 or 5 or less. Okay. But anyways, so same assumptions. Okay. But once again, here's a situation. Let's say that you're comparing two variables, A and B, right? Let's say you want to compare 3 variables. So you have to compare A and B. That's your original two variables. And then you compare A and C, but then also B and C, right? But that's not it, because there's also the comparison of all of them together. Okay. And like, let's say if you want to do 4 variables, well, then you do all these plus all of them all together. And so there's got to be this is a super tedious thing to do, like all these different chi-squares. And what log linear analysis does, kind of put them together and allow you to kind of determine which ones you should look at and which ones you shouldn't, without having to say, all right, what's the chi-square of this one? What's the chi-square of this one? What's the chi-square of this one? Okay. So we're using the models to determine which variables, if any, are related. Okay. We start with complex model and work our way to a simpler one. Each elimination, we're checking the significance impact of the variables that we removed from the model. The end model tells us which variables we want to look at, really, is what it was. So the idea is, it's like, since we're going from complex to simpler, we're working towards seeing if we can remove those complex variables without having to think about how do we want to do a chi-square analysis of those more complex values. Okay. So the idea is, it's like I said, we systematically replace them. And so what we do is we go from model 0 to model 1. We remove a variable. We test its significance. If it's significant, then there's a relationship that exists. But also another thing is, like, we're looking for the comparison between different categorical variables. So like our variables kind of look different, because if we're going between A, B, and C, instead of variable 1, variable 2, variable 3, we're doing A, B, A, C, B, C. So each of those variables that I was mentioning before is a different pairing of variables. And so again, we remove one of them, like BC, from here and check the significance. If the p-value is low, then BC is significant, and we say we like model 1. Otherwise, if it's not, If the p-value for model 2 is not significant, then we then we move on and remove another variable or do some sort of other arrangement, right? And so our basic strategy for like removing some of these is like, notice that like I have A, B, A, C, B, C. I remove one of them for each of those models after it. There's the same amount of them, but notice it's not the same pair of pairings, right? So we have AB, AC, AB, BC, AC, BC. So we're still just removing one. And then for model 5, we're checking to see if AB is also good, and then we check to see if just BC is good, and then if also AC is good. Okay. Anyways, so here is like the basic thing. And so when we're referring to a model and we're comparing all of them, well, whatever variable we're referring to, like for instance, ABC, we have to look at everything underneath it. Okay. So if we're doing ABC, we have to do AB, AC, and BC, as well as the individuals A, B, and C. If we were to add 4 things, which we're not going to, but just to give you the rationale, we have to include all these all below it. And so that's like how we're going to do things. Like we'd have to systematically remove them, and it'd be like kind of a tedious process, but well, no, it is a tedious process, but the important thing is that it's a far less tedious process of comparing doing all these intense chi-square tests. And we'll kind of take a look at what the chi-square tests look like of these individual things later. But anyways, we're going to focus on AC, right? Like, let's say we got to the part where we're just looking at AC. We need to make sure we have all the variables underneath it. So we have AC, AD, and CD, as well as the individuals below it. So we need to make sure we include in our model ACD, AC, AD, CD, A, C, and D. Okay. And actually, I'm going to put that in reverse order in the model. So it's A, C, and D, AC, AD, CD, and ACD. Okay. Here's what it looks like. Okay. Notice it kind of goes to the next line. And I mean, like I did say ACD, and I'll give an example of that in a moment. But anyways, we put these models in using the log LM method. Notice that the formula, there's that little tilde, which is great. It's very similar to our formulas before, but notice there's nothing to the left of it for you guys, right? And that's because we're not trying to make predictions. We're trying to see which of these variables, how they relate to each other, and that's how we do it. Data is not referring to the data frame, it's referring to a table, and it's a special kind of object that we'll get into in a little bit, but we have not worked with this object yet. Then also make sure you say fit is true. Fit tells R to estimate the expected values for each cell. Okay, so as I said before, for ACD, the model would look like this. So we have A plus C plus D, AC, AD, CD, ACD, and then data is table, fit is true. Okay, so it'd be referring to these find variables here. And then what we do after that is we test it and remove the variables. And so it would look something like this, like all the different possible models after that for ACD. Okay. And I'll go through this with an actual example in a second, where we are going to be looking at people's astrological sign, which is A, what they believe in astrology, B, and if the prediction came true. Actually, we'll be moving these variables around. So sign will be C, astrology would be A, and whether they came true would be B. So I'm just shifting things around. That way it kind of looks more like this, where we're taking this contingency table of if they believe and if it came true and applying it to each one of the variable types of the sign. That's how it kind of works. And you'll see what I'm talking about in a little bit, but this is how we do compare 3 things at once. We subset like all the Capricorns and look at their value. Like if it's a Capricorn, then do that contingency table for the believers and the non-believers and if it came true or not. Like we look at those for the people that said Capricorn. Same thing with the Aquarius and that sort of thing. Okay. So anyways, I'll show you how to do that in a second. But in order to do log lm, we use library mass. You don't need to install it. It's already there. You just do library mass before you do log lm, and you're good. Now, like I said, for table, we have to use a special type of object for that, and that's through xtabs. I'll show you how to do that in a second, but you refer to the data frame and you use the variable similar to how you did in or will with log lm. Anyways, the data that I got it from this right here. Anyways, let's go take a look at this in RStudio, shall we? All right, so here I am in RStudio, ready to do my thing. So here's the data. We're going to run it. There's a lot of observations there. If you notice that when we do the table for these, any one of these, everything's going to be in alphabetical order. But oftentimes when we're comparing these values, order matters for us visually, but not necessarily for our chi-square. Like chi-square doesn't matter the order or the log linear analysis, but it's kind of important for us for looking at it. Like for instance, so if you look at the table for the signs, notice that we have Aquarius, Aries, Cancer, Capricorn. And so when we compare these values, it's going to do things alphabetically. Now, for those of you that are familiar with the zodiac signs, that's not the order in which they occur. If you think about from earlier in the year to later in the year, it's more along this with Capricorn, Aquarius, Pisces, Aries, so on and so forth. So I factor these so that it makes sense. It doesn't really necessarily, we don't need to for the accuracy of our thing. It's like, because we're people reading it, it's important that it's a way that we can read it. Okay. So I have the levels. So we have unbeliever, believer, did not come true, and came true. So did not is the not come true, came true is it did. All right, so we create the contingency table, and remember this is with X tabs, and we're going to call this OBS. And so it's X tabs, and then we put the tilde, and then we put our variables. And so if we put them in order that they're here, so sign plus believe plus was it true? Referring to data is Zod data. And then we want to look at it. So I'm going to run this, and we're going to see what this looks like. Let's see. Oh, it's truth, not true. There we go. All right. And so notice that like what it did was it came up with, so like it subsetted it. So the people that believe, it looked at their signs versus unbeliever and believer. And here it's like the people that, oh no, sorry. This is, it did not come true. This is it. That's the subset. And it compared of those people that it didn't come through their sign and whether they believe or not. And then here it has their sign and whether they believe or not when it came true. And I feel like it doesn't make as much sense as if we compared, if we subsetted the different signs and then compared in each one of those believe versus true. I mean, it's all going to be like whether it's relevant or not, but I feel like if reading it, that's the most interesting way or way that makes the most sense. So I'm going to switch these around. So I have, let's see, this is between true and came true. So that's what I want the sign to be. So I want to take out sign here and I want to add it to the end because that's what's they're going to do for subsetting. So then when we run this, notice that we have Sagittarius, Scorpio, Libra, and it's all in the order because it's all factored, right? And so it's subsets, and so it looks at the different contingency tables for like this Leo. And of the Leos, the believers versus the did not come true and came true, that's the contingency table, okay? And so that's what we're going to be using. And so first we need to make a model 0. Model 0. And so we have log LM. And we'll just create all the models before we run them. So we have tilde, And so, like, in order to kind of keep things straight, we'll just come up with A, B, and C, and then substitute them in, because it's kind of easier to see the individual letters than it is to sign, believe, and truth. It's going to look confusing, and you'll see it in a second. But let's just put in A, B, and C for now. So we do like the individual things. So A, B, and C, and then all the pairings. So A, B plus A, C plus B, C plus A, B, C. Right? So that's all the possible ways that we could do this. Data is not our data frame. It's our OBS, our table. And or our few tables that we're combining all at once. And then this is lowercase. This is uppercase, right? Okay. And then, then we do fit is true. And then we take this whole line and we're going to copy it, and we're just going to remove the part where it's like A, B, and C all together. So this is model 1. And we're going to remove this. This is the most complex thing that we're removing, right? And so then we're going to look at A, B, and C together. We're going to only remove one of these. And so we're going to look at this model 3 times where I remove a different one of these. So first I'll remove BC, next one I'll remove AC, and then the next one I'll remove AD. So what's left is AB and AC for the first one because I removed BC, AB and BC because I removed AC, and AC and BC because I removed AB. So 1, 2, 3, 4. And so I'm going to rename these. So we have 2, 3, 4, 5. And so for this one, remember I'm removing one thing. So I'll remove BC, I'll remove AC, and I'll remove what did I do wrong here? Did I have an extra one? I guess I did. Okay. So 3 the same length. I have all together, just ABC gone. All right. So now I need 2 more of this. And so instead of removing 1, I'll remove 2. Actually, I'll just do, okay. So remove 2. So remove BC and AC. Remove AB and BC. And we'll remove AB and AC. So all we're left with is BC, right? And so notice that since we have, for these 3, we have AB, we don't use C, so we can get rid of C. We have AC here, so we can get rid of B. We have BC here, so we can get rid of A. And then last, we'll do all the individual ones together without the... All right. And so we need to keep up with these numbers. So we have, this would be 6, 7, and 8. Beautiful. All right. So notice when we run these, it doesn't like it. It says could not find function log lm. That's because we did not run the library, right? And so even if this is your first time, don't worry. Mass is already installed. You just have to load it. So library, MASS, it's capitalized, run it. Now it works. And now when we run it, notice it still doesn't like it. Because notice that A, B, and C aren't part of our table. X tabs, it's believe, truth, and sign. So we have to replace all the A's with believe, all the B's with truth, and all the C's with sign. And the way that we can do that is with this. So we could do A with believe. Actually, I'm going to copy and paste so I don't end up making any sort of typos. we want the whole word and match case. So replace all. Good. And then we do that with B, except we don't want it to be believe, we want it to be truth. All. And I didn't point this out, but what we should also do is it kind of highlights the ones that it's going to be replacing. So we want to make sure it's just the ones in here and not anywhere else. Otherwise, it's going to be confusing. And so notice that's what it's doing. Okay. But make sure you have whole word and match case selected. Replace all. Should be 19. And that's it. And so notice instead of A, we have believe. Instead of truth, we have, or instead of B, we have truth. Instead of C, we have sign, so on and so forth. And so now we're pairing each one of those values up. And notice how long this is. This is kind of confusing, and it's easy to mix things up. So that's why I did the A, B, and C first, and then substitute that in. So now when I run this, I get my models. Beautiful. Notice that, oh, I have an issue with 6. What's my issue? Oh, you see it? No comma. Run it. Now it's good. Oh, and then we have to do 7 and 8 again. There we go, because I didn't have them. All right, now to determine which one I like best, I use summary. Model. Oh. When I run it, we're going to be using the Pearson at the end. So this is kind of a long value, but Pearson, the Pearson is the Pearson p-value for chi-square is 1. That's what we want. We remove that. It's always going to be 1, the model 0. If it's not, then you made a mistake somewhere. So I just say that not so you can skip it, but so that you can check it. It should be 1. It's 1, so I feel rest assured. And so then I'm going to copy this and go here, and it should be 1. Run it. Notice that the p-value is greater than 0.05, so I don't like that. So I do it again. Notice the p-value is greater than 0.05. I don't like that. Still greater. Oh, this one's less. So model 4 is less, and so this is the one we like. So the idea is like the p-value. So we remove the whatever value we remove from model 3 is significant. So we want to look into those models further. So we're going to say model 3 is the one that we like. And so model, let's see, model 3, we have believe, truth, believe, sign. And we have believe, sign, truth, sign. The thing that's not here is believe, truth. That's the relationship that it seemed to like. So we removed it, and so that should be significant. Okay. Anyways, so that's definitely one that we would look for further into. But since we said we liked model 3, we'd also check truth and sign as well. But the important thing is like we don't have to check all 3 of them all together because they didn't seem like they were in a relationship, which is great because that's annoying. So it saves us a lot of work, and that's the point of log linear analysis. Anyways, I think that's good for the practice problems. We'll go over the answers on next class. See ya. Bye. Hey everyone, hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message to both me and the rest of the teaching team in Canvas, and we will get back to you as soon as possible. Don't send it through normal email. You will not get as fast response. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for the next video. Anyways, I think that's good for now. See y'all later. Bye.